on efficient integration of libraries. In the hackathon title has our own libraries, but obviously in the workshop, the idea is to cast the net quite a lot broader and see how does everybody do this. So if you like, this could be a meta workshop on open source software, yes, not in the context of ex-Facebook, but we see how do we do these things, and then everybody implements it in their own framework, because I think it will be hard to come up with one framework that does everything that we need. Yeah, so learning from each other. Just as a bit of background, we have this is organized by two collaborative computational platforms, which I only at the moment have Synergy on the slide because I didn't have time to make my update my slide.
I've got a CCPI slide.
But I've got the stickers for
right. Okay. So you will hear about it. So the collaborative computational platforms are a UK networking grant that is probably fairly unique in the sense that they fund networking activities, but they also fund a group of what used to be called research software engineers. I don't know what you guys are called these days, but that are part of STFC's Scientific Technology Facilities Council, something.
Science Technology Facilities Council.
Yes, so it's part of UKRI, but it's also not part. So anyway, that's not.
No, it is part.
Yes, but
it wasn't.
Yes. Anyway, so there's a group called COSEC there with about 50, 60 people in there, I suppose, of which a number of the people here are in the room, and we as grant holders can't really tell them what to do, but nevertheless, we suggest what they do, and then they do it anyway. Most of the time. So we have two of these. So Synergy concentrates on PET, SPECT, and MR type of reconstructions, mostly synergistically. So we want to do things, the reconstructions together. So you have multiple modality data. Can we reconstruct all of that data in one framework and with one reconstruction algorithm or things like that? But in addition, we want to use Synergy to learn from all the different communities, obviously. And CCPI originally was mostly X-ray and material sciences, but they're branching out to many other things as well. So, and you'll hear more about that later. So these are networking grants. We have funding now until October 26, I guess. Then we hope there will be another renewal. So Synergy has been going for about 10 years now, and CCPI 15 years. So it's quite remarkable as a funding mechanism. And that allows us to do things that other people potentially can't. So you saw 3 bits of software mentioned there in the title for the hackathon. So I'll very briefly just discuss what these different software libraries do. So the first one is STIR, Software for Tomographic Image Reconstruction, which originated, I think, 25 years ago. And so it's obviously been around for a long time. We initially wanted to do everything, but in the end, practically, it's only PET and SPECT, although the framework is set up to do other modalities as well. It's mostly C++, and there is a Python interface to it that is automatically generated via Swig for the people who know that. So you have your C++ code, and then you have a very small interface file, or actually a few files that say, read this header, read that header, and so on. And then Swig will create the Python interface for you. So it's an almost, not quite, but an almost zero effort exercise once you know Swig a little bit. We don't do that very well, but it allows us to have an interface in Python and in other languages, and we for a while we played around with MATLAB that way as well. So that is it grew over the years. Obviously, it's set up to be entirely modular classes, so lots of object orientation in two ways. One is the traditional you do class derivations, and the other one's using templates. So generic programming, that's sometimes called, and templates don't really transport very well to Python. So in your Swig interface, then you have to say this template I instantiated for floating point numbers or stuff like that. Yes. It's all open source, obviously. We aim to be complete in the sense that we do also, scatter estimation and efficiency of the scanner and all of those things. It obviously is not complete, but that's our aim. This is forget about the people who are highlighted in bold there, because that's from an event from last week. But so we've had a lot of people contributing over the years, not all UCL, because it's way older than when I arrived here at UCL, not older than me. And that's obviously a little bit hard to keep all of that together and to make sure all of this stuff is still coherent in some sense. So we have the usual things like continuous integration, all lives on GitHub, and there are automatic tests running, and there is more and more sort of code verification in there as well. So we're learning from our CodeSec people on how to do that properly. And we, since recently, thanks to Imraj, have one, I think, class that uses CUDA directly. And that obviously is why we have these types of discussions. Then with Synergy, we created sort of a framework more that would allow us to do synergistic image reconstruction. So we wanted to do PetMR originally, and then SPECT came on later, and there are potentially other things like CT can be incorporated. And then the question was, well, how do we implement all of this stuff? One logical choice might have been to stick everything into STIR, but as obviously a lot of good software are already out there, and so we felt that was maybe not a good thing to do. However, it doesn't say that on the slide there, but we made the decision to have that interface of talking to these different engines on the C++ level as well. And then we want to get that to Python. And so the way that this was done, because originally our community said we need MATLAB. And so if you know MATLAB. And so what Evgeny there did was to say, okay, I have my C++ things, but I make a C library that calls the C++ things, and that C library is actually what is interfaced to Python and MATLAB. I'm saying all of this to show you the number of layers that there are in this game, right? Which is a problem. Then the third bit of software that we are using is the core imaging library, which Gemma will talk much more about. But just one header here is this is really intended as a Python framework to call other things via an interface with plugins as well. So Gemma will say all of this. All of these softwares are Apache too, so anybody can do whatever they like with it. STIR has been selected as the reconstruction library of a new brain PET scanner, so which is FDA approved. So it's working okay. However, you have all these layers here, yes, and now we say, we want to talk to PyTorch, and we want to do that efficiently. And that obviously, the more layers you have, the harder this stuff becomes. And so you'll have a talk from Imraj later on how we do that, and it works nicely from an abstract level, and it doesn't work so nicely from a performance level. Yes, so we can do it, but the question is, how can you do these things efficiently? And we thought, well, the best way to start with that project is to learn from other people and how have they done that. So a number of layers. Can we get those layers somehow exposed to PyTorch without having to copy data objects from different types and up to tensors and all the way back again. So that is sort of the question that we are facing, and that's what this workshop is about. I guess, yeah, I think we have just a tiny bit of time. I think there are obviously a lot of challenges in open source development, and most of us don't do this as a job, we do it on the side. And I think that's probably true for all the other projects as well. So we always want to have some new science there. And I don't know if this will be possible, but I thought potentially if the workshop and hackathon gets into something useful, maybe we could submit an abstract somewhere to a conference or so, or to sort of show that we're working together, and that's all good for our CVs as well. So we need to be sustainable, and so we need to have all that testing and the test data, but we need to be able to have contributions, but it also needs to be simple enough. And that's a problem with the layers. We have large code bases, so we need to think quite hard on how to do this optimally. And we're struggling to keep up. So that's not just with the software side, but it's also on the hardware side. I don't know, certainly this is true in more and more data sets, sequences, all of that stuff. It's in CT, you have more and more, you have energies and smaller detectors and more sources, and in PET you have longer and longer scanners. There's always more data being generated, and we need to be able to handle that. And I think for us, for instance, it might be possible to say, oh, we have our images on GPUs, we have our data on GPUs. After a while, it becomes impossible. Yes, there is no expensive enough GPU that we can buy that has all that data. Maybe if you have one computer with 50 GPUs in there, but we just can't afford that. So how do we manage that in our software? I'm not sure. Yes. So I'm trying to sort of set the scene for people to think what we want to talk about. And obviously, we need to keep up with the science, and therefore all the things that are happening on the deep learning side, we want to be able to benefit from it, but also contribute. Yes. So, all right, that's it from my side. Any questions on this introduction at all?